All right, so the domain of a function are all the x values that work for that function. So it's the x values that we can use, okay? It is not really, domain, it's not, it's what causes the range. It's not necessarily the other way around. The domain are the x values that we use in the function. Domain starts like the generic domain, if there are no exceptions, is going to be all real numbers. And we're going to start using this thing called interval notation. Okay? And the interval notation for all real numbers is parenthesis, negative infinity, comma, to positive infinity in parentheses. Now, we'll get better at interval notation as we go along because we'll eventually just exclusively use interval notation the whole time. But the parenthesis is not, this is not an ordered pair. This is an interval. This means starting at this x value and going to this x value. So the parenthesis in interval notation means you're not including that number. You can never get to negative infinity, so you can include it. Okay, so a parenthesis is going there. If you are including the number, you use a square bracket, and we'll see that as we go through working on some of this interval notation as we go here. But we're starting at negative infinity and going to positive infinity. What we're going to be looking for when we're trying to find the domain are these red flags. And there's only 2 red flags that you have to look for. So it's a really simple idea, but it can get kind of complex in the equations that you deal with or the functions that you're dealing with. The red flags we're going to look for are that x's are in the denominator. You're dividing by a variable. Okay, that's division by 0, possibly. What we've got to find is what x value would make it division by 0. Okay, and we'll see that as we get to some problems here. The other red flag that we're going to be looking for are square roots or even roots. Remember, when you take the square root of a negative number, what kind of answer do you get? Imaginary. Okay, so when we're dealing with domain is only on the real number set. It's not on the complex number system. So we've got to take positive only for that. And I'll show you how to take an equation that has a square root or a fourth root or something like that and work with that to find the domain. Not necessarily that we're solving equations here. We're going to solve some equations. We're not going to solve really complex ones yet with that. But these are the 2 red flags that we're going to look for. If there are no red flags, there's not division by an x, there's no square root in the problem, then your domain is going to go back to the default, all real numbers. Okay? That's your standard domain. These red flags are what changes it. Okay? So your standard domain is from negative infinity to positive infinity, and then if there's red flags, then that's when it changes. Okay? So we're going to look at some functions and see if we can find the domain, and then we're going to work on, we'll do set notation, which is the inequality style, the way you've done for years, and then we'll do interval notation, which is the more college level style, and that's what we'll kind of try to transition in this first chapter over to interval all the time. We'll kind of bounce back and forth during this first couple of sections on this stuff. Okay. All right. I'll scroll down a little bit. We'll get our first example of the day. All right. So we're going to find the domain. That's what our job is for this set of problems. So here's our function. We know it's a function because it's in function notation. And x squared plus 5x minus 7. Okay. So we look at that and we say, okay, we know it would be a parabola, right? Because it's x squared. And we know it's a function already. We don't really have to worry about that. Are there any red flags showing up for this problem?
Yes.
There are? Where's the x in the denominator? Oh, there's not one, because there's not any fractions. Is there a square root? No, there's a squared, but that's not a square root. Square roots and squares are opposites of one another. Okay, so there are no red flags in this problem. So what would the domain be? All real numbers. Okay, so I'm making a note here, no red flags. Well, that's just kind of something, what's what you want to think when you're doing that. And then your domain is in set notation, the way we've done it in the past, or the way you should have done it in the past. All x's such that x is a real number. That's, or you could even write just all real numbers in that spot. That's the set notation. Interval notation, this is set. Interval is negative infinity, positive infinity. That's interval notation. This is all the x's toward negative infinity up to all the x's toward positive infinity. That's what that means. And you can see this is shorter here. There's going to be times interval notation is shorter than set notations. There's going to be times that set notation would be shorter than interval. But what we're going to be trying to do is kind of figure out, okay, how do we write it in either form there? So both forms kind of be handy this first chapter. We'll eventually work toward just using interval most of the time. All right, so let's take another example. Here's a function, 5x over x plus 3. Any red flags? Yes. Yeah, we got division, and there's a variable in the denominator. So there's a red flag there. Okay, so that tells us that we could have possible division by 0. What number would make that division by 0? How do you know that? Good. Yeah, because x plus 3, when does it equal 0? Yeah, when it's negative 3 plus 3. So really, you're setting that denominator equal to 0 and saying that negative 3 is the x value that causes a problem. So what we've got to do is cut that out of the domain. That's what we've got to do. So the set notation for that domain is actually really easy. X doesn't equal negative 3. That's the set notation, which is really, really nice and easy. The interval notation for that, a little bit more difficult because you're having to carve it out of the negative infinity to positive infinity. So if we're going to scoop out the negative 3 out of this whole set, what we're doing, and I think this will maybe make the interval notation make better sense on this problem. So we think about a number line. Let's put negative 3 there in the middle. What's out here? Negative infinity, right? To the left. To the right would be positive infinity. So the interval notation, all the answers are everything except that. So it, the kind of the number line graph of that looks like that. Okay, so when we go to carve that out of interval notation, we're reading it left to right. So we start at negative infinity, and that's still good. So we got negative infinity, and then we get to the 3, and we've got to jump over it. So we got to tell it 3. Don't include 3. So in interval notation, if you're not including something, use a parenthesis. Okay, we'll get to some in a minute where you are including the number. And then we've got to go past that. Yes. It should be negative 3. Yes, I knew that's what you thought. That negative, it should be negative 3 there. So from negative infinity up to negative 3, and then we're going to jump over the negative 3. Yes. Now, how do you put it together with interval notation? We use a U. That stands for the union. That's joining two things together. So we start at negative 3 up to positive infinity. So this is the interval notation for what that set notation says. So it's from negative infinity, and we're hopping over the negative 3, and then we're going on to positive infinity.
So when we write our answers, will it be both of those?
Yeah, today, both of those. But as we progress through the semester, we'll eventually just only do intervals on a lot of different things that we do. Okay? So we're going to use interval notation on a lot of things. So kind of the idea here today and, well, maybe next week as well, is be able to do both forms, interval and set form, and that way we can bounce back and forth between those two. There are some things in this course that we use interval notation exclusively for, and then there are some things that set notation is kind of handy for as well. So we got to be able to bounce between both of them. Interval is used more often in this course than anything, right? All right, what that means is it's all the x's such that x doesn't equal -3. That's the way that's the notation for that. It just means all the x's as long as x isn't -3 is what that's reading. You know, that's the notation for that. Okay. All right, let's go to another. Example C. H of x is the function 12 over x squared minus 16. Ooh, that's any red flags? Yeah, we got an x in the denominator, so that's a red flag. I like that. What do we do with that? Good. Set it equal to 0. Absolutely. Anybody remember how to solve that?
Add 16 to the other side and square it.
Okay, that will work. That's one way to do it. Anybody know another way? I like this way. This is the way I would do it, but. So what's my answers? Just 4? Positive and -4, so plus or minus 4. So we get two answers, two values for x that can't be used. Okay, so why is it plus or minus anyway? Because it was a square root, so if you take the square root of a number, remember you got to put that plus or minus in front of it. If you put the square root in the problem, okay, that's when that happens. So with our set notation for the domain, x, as long as x doesn't equal plus or minus 4. Really easy there. The interval notation, think about the number line. If it helps you to draw one, go ahead and do that. But what's the first part of our set or our interval notation? Up to -4. Are we including -4 or not? No, so it's a parenthesis. And then u, because we got some more stuff.
+4.
-4 to +4, yeah. Because we got all those numbers in between there that work. And then a u. And then the last piece. 4 to infinity. Yeah. And there's our domain. Just to make your life miserable. No, it's not. Because you'll need it later on. Okay? Trust me. All right, let's look at the next. F of x. The square root of 2x minus 6. Red flag. Got a square root in the problem. What kind of numbers can we take the square root of when we're talking about domain? Positive only. So, or not, is it positive only or is there something else included? Positive only would be like 1, 2, so on. We can also take the square root of 0, can't we? But we can't take the square root of a negative number. So we need what's under the square root to be 0 or bigger. So we set that 2x minus 6 greater than or equal to 0. Whatever's under that square root, or if it's a fourth root or sixth root, even roots, set that greater than or equal to 0. Okay, and solve it. It's just an inequality, really simple. Divide by 2. We didn't divide by a negative, so we don't have to flip the symbol. So x is greater than or equal to 3. Okay? So when we start talking about the domain, that's the set for it. X's are greater than or equal to 3. Kind of the difference in the inequality style here is we're not changing this. You know, on the equation where we set the denominator equal to 0, when we went to the domain, we made that a not equal to sign. Here, we're leaving it exactly the same. Nothing's changing about that. Okay. All right. Now, what's the set or the interval notation for this? It would it? You're not missing any, so we're going to include the 3. So it would be 3 to infinity. Now, a parenthesis says you're not including it. A square bracket is what says the 3 is included.
Ethan Purvis, report to the office.
Okay. Parentheses says you're leaving that number out. Square bracket says this number is part of the domain.
So you do that as a line of it.
Yes, because we have an equal to mark. I did that. That's correct. And we will go ahead. You don't. You leave it exactly. That's the difference in the inequalities, the radical stuff and the equation part is the fact that you don't change this at all. These are the ones that work. Because we set it greater than or equal to 0, that's what we need to happen. Where what we were doing on the previous problems where we were looking for what's gonna mess this thing up. So that's why we had to do the not equal to. I guess technically,
You're not using negative infinity. Is it because of the?
because it's x's are greater than 3, greater than or equal to 3. So so negative infinity is part of the cutout of here. A bracket on the 3, a parenthesis on the infinity, because you can never really get to infinity. You always just add 1, you go further. We'll see some more of this. You ain't gonna. We ain't done yet. All right, so let's say is our function 7x minus 3x squared. What about the domain of this? Any red flags?
Nope.
No red flags. So what should our domain be? All real numbers. I'll just do all real numbers. Or you could write x is a real number. What's the interval notation for that? Negative infinity to positive. You can say negative infinity to infinity. I always just say positive. Yeah, it makes it sound fancy. You don't sound fancy. Don't talk about math. All right, so far so good. That one's really easy. That's easy when that happens. And Dylan, you were saying, why would you use this? The interval notation is much more descriptive than the set notation is. It has, I mean, it's longer, but that means it's got more detail in it. That's one of the reasons that it's used a lot is because it has more detail in it, and to make your life harder. That's real. All right, so let's look at this one. Little bit of a difference on this one. Red flag. Why? Got a square root. Got an even root there. So red flag. How do we find the domain of that square root stuff? Set it what? Greater than or equal to 0. Yes, because you always want it to be positive numbers or 0. 0 or greater. So it's always going to be greater than or equal to 0. we might find an exception where the 0 gets left out. We'll get to that in a minute. But I think you'll see why when we get to that problem. So let's solve this thing. Really simple algebra here. It shouldn't be string. Whoops, I'm getting ahead of myself. Solve it before I get solved. Divide by -2. What happens when you divide by a negative with inequalities? Yeah, swap the symbol around so that it's positive 4. X is less than or equal to positive 4 this time. So a little different, but the set notation for the domain, again, all x is such that x is less than or equal to 4. Now, the interval notation. If x's are less than or equal to 4, where's it starting at? Parentheses, negative infinity. No, I didn't. Parentheses. Because you can't get to negative infinity or positive infinity. You can't include those because you can never get there because you can always just add more or take away more. So where are we going to from negative infinity up to 4, and we're bracket because we include the 4 because it has equal to mark. Yes, ma'am. No. Because I didn't take a square root to solve it. That's the only time you're going to use that plus or minus is if you take a square root or an even root of some sort to solve the problem. If there were an x squared like x squared is equal to 28 or something like that, that's when you would take a square root to solve it out of that. All right, let's look at a couple more. All right, so let's throw one of those in there. Let's say we had 6 over square root of. It's not that bad. Definitely a red flag. Not just one red flag, but 2 red flags because we have, not only do we have an x in the denominator, we've got a square root in the denominator. Okay, so this one's got 2 red flags going on, so we got to be extra careful with it. Okay, so we think about that. We think, okay, if it were an x in the denominator, we had to find out where that thing was equal to 0. And then we did what with that answer? We cut it out, right? We got that answer and we cut it out of the domain. So with it being a square root in there, we also know that those numbers have to be what kind? Positive. Okay? But so we've got an inequality set up. So instead of setting up x minus 7 is greater than or equal to 0, we're going to set up x minus 7 is just greater than 0. Because it can't be 0 because it's where? In the denominator of the fraction. So that's why we lose the equal to mark here, is because that square root was in the denominator. So this is kind of that exceptional thing that's happening. Okay, and then we just solve that. Add 7 greater than 7. So our domain, again, this is actually easy on both versions. X such that x is greater than 7. And what's the interval for that? No bracket. So by the 7, we're going to have a parenthesis, and it's going to go to positive infinity. It's a parenthesis.
Why is it not a bracket?
No, the numerator doesn't affect it in this case.
Why is there not a bracket?
Is the 7 included in the answers? I'm asking you. Look at your inequality. X is greater than 7, so would 7 be would 7 work in that inequality? No, because 7's not bigger than itself, right? So it's not included. That's why we don't use a bracket there.
So what if there was a square root on the 6 and it was just
Excellent. Excellent question. Excellent question. Are you by chance psychic? Would you know if you were? All right, so let's look at this example. Kind of go with what Vivian was asking about here. It's a function because it's written h of x. It's a function. And we're going to find the domain of that. So what do we got going on here? We got 2 red flags. They're not in the same place though. So does that make it any harder? Not really. I think it actually makes it easier than the previous problem because it's just 2 separate things to worry about. Yeah, we just got to work with it separately. So let's look at this one. We got a red flag up here in the top. We got a red flag in the bottom. Okay. What to 0? Do you? What to 0? What do you mean? Equal to 0? Do you mean less than 0? You mean less than? Greater than? Or equal to? So it's in the numerator, so it still has the equal to part. Because it's okay if you divide into 0. 0 divided. Let's get that. X, is it plus or minus? It's just negative 5. We're finding where is the stuff that's inside of the square root, positive or 0. So the square root symbol, if you put it there, if you square both sides, you'd still end up with the same equation or equality to solve. But you just drop it off because it's one less step. All right, so that helped us with the first red flag. Let's find the second red flag stuff. What do we do with it? Set it equal to 0. X minus 8 is equal to 0. Solve it. So x can equal 8. Yeah, that's the number that's going to be thrown out. Okay. So when we go do our domain, this is where it gets a little hairy. Well, we're going to have to include both of those in the domain. So with the set notation, it's really easy. You just say, okay, x is greater than or equal to negative 5, and x is not equal 8. Okay, x is greater than or equal to x is about 50 minutes or 40 minutes, and then tomorrow to work as well. All right. Tomorrow's Friday. Yeah. No, I just finished. I'm being nice. Unless you don't want me to, I can undo that because tomorrow isn't here yet. So. Yeah, sure, absolutely.